Hey yo, what's up guys? Baby Bear 4812 coming at you one more time. Today with problem number 380, insert delete GetRandom O of 1. So this one's a bit different, and what I'm thinking of doing is kind of in addition to the standard algo problems, I want to start doing a bit more object-oriented design questions. Let me know down below if you'd find that helpful. Maybe I can break off a separate playlist for those. So this will be the first video of an object-oriented design problem. It is being asked by Facebook, Amazon, Bloomberg, Google, Microsoft, a whole bunch of the big boys, and interestingly enough, there's quite a trivial solution to this one, but the follow-up really, and the solution we're going to focus on will be if we can implement, all this stuff with an average O of 1 time. All right, we will be able to, but if you're not familiar with this problem, as always, pause the video, give it a shot, come on back. Otherwise, let's read through the requirements quickly. I've kind of cleaned it up a bit here, so we're working from a blank template. I'm not sure that whiteboarding will be very helpful here, so what I'd like to do is maybe just have a bit more of a discussion base, and we'll kind of talk and code at the same time. I think that'll get the job done a bit better than just than maybe whiteboarding in this problem. So let's dive into what it says. We are told to implement a class called a randomized set, okay? And there are three, apart from the constructor, there are three methods we want on that class. Well, the first one will be insert, which will insert a value into the set if it is not present. We will return true if the item was not present, otherwise false, okay? Then we got remove, which removes an item val from the set if present, and it'll return true if the item was present, false otherwise. Fine, that's not very fun. Then the interesting one, this is get random, which returns a random element from the current set of elements. Okay, it's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. Fine, again, O of 1 time. So, a couple things to think about. So, we have three items we want to do. I said no whiteboard, but it always finds its way in. Let's try this. First one we want to do is we want to do an insert, okay? So we want to insert an item, and essentially, what we're told is that we want to insert it and we want to say whether or not the item was already present in there, okay? So, inserting, we can insert to a list, we can insert to a hashtag, we can insert to a set, it doesn't really matter. Like actually inserting an item is trivial and we can do that in O of 1 time. The question here becomes which data structure is most appropriate to use if we want to then check prior to adding it in, we want to check if it's already in there, all right? So an array or a list, sure, we can do it. The issue is we'd have to loop through the entire array, which would potentially average O of n time to check if the item is already in there. So maybe we think to ourselves like a set or a hash map will lend itself better here. So if we only need to insert the number, maybe we can say set, and then let's say maybe a hash table, maybe with a question mark, just something to consider. All right. So I think for that first method, a set or a hash table probably make the most sense, and we'll get back to which we can use in just a bit. The second item was remove, or the second method, excuse me. All right, so similar idea here. Removing an item from a set or a hash table is pretty straightforward, so that should be easy enough. Again, with a list, not as easy. The reason is because if I've got a list of, a whole bunch of numbers, I know I've ordered them here, 17, -5, so on. What I need to do is I first need to actually walk through item by item, O of n time, to find the number. And then to actually delete it, let's say I want to scrap the 3, once I delete this, everything else needs to get shifted over, which is going to take O of n time again. All right. So in this case, definitely it's not a good idea to use an array. So I think we're pretty confident that again, we can, maybe I'll do this to kind of copy down. We can use a set or a hash table for these two. Then the third one was to get a random number, and again, or a random element. And the random element needs to come from the current set of elements. I've kind of been assuming they're going to be numbers, but I guess they don't need to be. They could be letters or anything else. Each element must have the same probability of being returned. Okay, so this is where it gets a bit interesting. Whoops. A bit interesting. What did I say? Get random. So now all of a sudden a set or hash table may not be so sexy, right? If we went with that route, how do I select a random item? I can say, let me grab the size of the set, and let's say I have 10 items, and I can generate a number between 1 to 10 easily, right? That's pretty trivial. but then I can't use that as like an index to pull a number out. So what I'd have to do is maybe set up a loop and walk through the item random number of times, that random number we generated. Eventually when we get to that ith item within the set or hash table, then we delete it. So the deletion is instant. There's no rearranging of sizes, so that's nice, but we still need to walk through in linear time to find the item. So then we tell ourselves, okay, well that's no bueno, but you know what we can do is we can do it with an array. So with an array, like if I had these items in an array or a list, I could use indexing. So I could generate a random index from 0 to n-1. And once I use that, I can then say, let me return this number, okay? So again, all of a sudden now an array seems like a potentially good idea. But again, the issue is here, if we kind of get that number and return it, that's fine. But you know, we saw how not great the array was for inserting and removing. So what do? The truth is actually we kind of do both. And this isn't the first time you're going to see this. So this is something that's common outside of just object-oriented design. In the OOD questions, it's not too uncommon to use multiple data structures. So you're potentially maybe offsetting, you're paying the cost of space to save on time. All right. So the space here would still be O of n, even if we're using two different data structures. The real space taken would be double. So again, for your asymptotic analyses at your interview, you'd say it's still O of n space, but in real space, it will take up more. All that said, we still need to get a bit clever about how we're going to merge these two so that they live together. All right, because they somehow need to communicate so that I can say at any given time, if I was to remove an item from this set or this hash table, how do I also remove it from the array? So this is the tricky part, all right? Let's say I choose to remove an arbitrary item and we're like, cool, I can remove in constant time, no problem, I got a set. Fine, I remove it. But now if we want to generate a random number, that number can't be in the array anymore, right? We need to take it out of the array as well. But the reason we did the set here is because if we did an array for removal, that would take O of n time. So it's like, what the heck do we do now? And that's the question. If you can basically get over this mental hurdle, you've answered the question. So the big part, well, two big parts. One big part of this question is recognizing that you'll need two separate data structures, all right? The second hurdle you need to jump over is to realize how to remove items from the hash table or the set, and somehow remove them from the array in constant time. All right, so I'd encourage you to pause the video here, think about it for a few minutes, and come on right back, and then I'll spoil the fun for you. So, what if we did this? Now, what if we did it? This is going to be the answer, right? The trick here is to actually use a hash table instead of a set. Okay, so hash. We're gonna use a hash table. The reason we're gonna use a hash table is because apart from just, maybe I'm gonna add my value in, and then when I add my value, I could also track the index that I'm gonna put it into my array at. All right, I can keep some sort of global counter, or maybe some sort of counter index right here in my constructor, which I can track as I add and remove items, so I can increment or decrement it. And then I can say, let me keep track of all these values and what index they're at. Then, when it comes time to remove an item from the array, what I need to do is I need to find that item. Say that item is the number 7, and last number is 0 here. I need to swap that item with the last element in the array. I swap the items, then I delete the last item. Deleting the last item in the array is constant space. Swapping items is constant space. And this is the quantum leap of problem solving and imagination that you need in this problem to get over that leap. Again, the first part was understanding that we need to use a hash table and we need to use an array. The second is to say, if I now want to get rid of items in the array, I need to track what index they're at in the array using my dictionary, swap that item at its index I with the last element in the array, and then delete the now last item. And of course, this item now, this 0 that we're swapping will be in a new index in the array, so we've got to update that as well. So yeah, that's really the key. And this is why I love this problem, is because it just, again, there's a quantum leap of imagination that takes place, especially in recognizing this. If you've never done this before, if you've seen this, then maybe it's not as exciting, and well, in that case, you might not even be watching the video. But first time I saw this, I thought it was wicked cool. which maybe says something about my definition of cool, but I stand by it nonetheless. So yeah, this is the general approach we're going to take, and I think we're good to dive into some of the code now and see how that's going to look. So we have our constructor, and we'll want to do a couple things. So one is we need our dictionary and the list as well. So maybe what I'll do is I'll define something like valdict and set that equal to an empty dictionary, and I'll do self.val list and set that to an empty list. The other thing I said we're going to need is we're going to need to keep track of an index, like a global index counter, so that when we're adding and subtracting numbers, we're keeping track of what index they fall into. All right. So I'll say self.index, and it's going to start at 0. All right. Now we'll couple of these pieces are more trivial than the others. I'm thinking maybe I'll just do them in order. Yeah, I'll do them in order as they come. I was going to jump around a bit, but no need to make it confusing. So let's read carefully the instructions again. So for insert, we need to insert an item val into the set if it's not present. Okay. We return true if the item was not present, false otherwise. So if it is present, we return false. If it's present, we return false. If val in valdict, return false. Okay, we can just take care of that right off the bat. Now, we actually want to add in our dictionary and our list. All right, and I realize I should probably move this over a bit. Right, we need to add into our dictionary and our list, because if we make it here, it means that it was not already in there. And the reason I'm checking in dict and not list is because of that instant time lookup. So now I tell myself self.valdict of val is equal to index. The reason I'm setting it equal to index is because I'm now going to go to my list and go to val list, and I'm going to append the value, which is now going to be at index 0. It's the first item I'm adding in. Every time I do this, I'm going to want to increment the index by 1. The reason I'm incrementing by 1 is because the next time I'll add an item, it will be in the 1th index, then the 2nd index, then the 3rd index. Similarly, when I remove, I'm going to be taking that index down, so we'll take that into account. But so far, that's the first thing that we're going to be doing, and I think at this point it said return true, right? So we're returning true if an item was not present. Cool. In this case, it was not present, so we're returning true. So that was the first method. Okay, that was the insert method. Now I think the remove one is a bit trickier. So that's all right. We can handle it. The remove one says to remove an item val from the set if it is present. Okay, we will return true if the item was present, otherwise false. So maybe we can just say if val not in valdict, we'll return false, right? Return true if the item was present, false otherwise. So I'm going to do this right off the bat here, because if it's not present, there's nothing to remove. So I'm just going to return false. I got nothing to worry about. But again, that's kind of the easier part. This is where the slightly harder part is. We want to now say, so kind of looking back here at what we were doing before, we need to say, let me figure out how to swap these two variables, update this in the dict, and then pop it off the array at the end, right? And then decrement my index. So a few things here. I know at the end of this I'm going to have to return true. All right. So a few things I'm going to have to do is I'm going to have to swap items, update index of, I'll call it the old. Oh, do I want to call it a tail? I'll call it the old tail. I know someone's going to yell at me for this. I know it's not a tail. I'm like borrowing linked list language. But what I'm going to be referring to here is this kind of old, this old final element that we had here. All right. So I'm going to have to do that, and then I'm going to have to decrement index, and I'm actually going to have to delete it. So I'm going to have to delete final item from array. Okay. So each of these is going to be its own set of steps. Now again, I'm kind of breaking this out just because I hope it helps follow. It helps with the logic of it. To swap the items, we need to actually find the index of the item we want to swap. So maybe I'll call that I. I'll say I is equal to self.valdict of val, right? So what that's actually going to give us is this index that we've been appending right here. That's the index of the item I want to swap. To actually swap them, I've got to say self.val list at I. And I want to swap it with val list of -1, meaning the final item in the array. And in Python, it's super easy. We can do it in a one-liner. So we just swap them this way. I goes to -1, and -1 goes to I. Val list of I. Cool. So we swap them. Now I want to update the index of the old tail. So, maybe if I'm doing that before I even swap them, I want to save something like old tail is equal to self dot list of -1, meaning just so we have a pointer at that last item. We could have called it temp or something, but I want it to be just a bit more descriptive. So we update that index, and that means that we're going to have to do self.valdict of old tail is now in that position I. All right. So that's where that exists now. Spread this out here. We want to decrement the index, and that means that we're going to do self.index minus equals 1. And finally, we want to delete the final item from the array. So we're going to want to say just delete self.val list of -1. And actually, we're going to want to delete this from array and dictionary. Okay, so I think what I actually meant to do here was I wanted to delete it from the dictionary by deleting that specific val, and then I want to say self.val list.pop. Right? We know how to pop. Sorry, I was overthinking it. So that should just about do it for the remove method. Again, what we're doing is we're going to swap the actual elements. We're going to remember the index in terms of where we want to swap our old tail or old ending to. We're going to remember what our final element was before, so we can update it in the dictionary. We'll have to decrement our counter index so we know where we're going to be inserting new items to in the future, and then we want to delete it from both lists. Finally, we return true as per the instructions. All right, and now the easiest part of this, which is going to be to return a random number. So I'm just going to call it rand, and what I'm going to do is I am going to generate a random number that is that's based on how long our list is essentially. So I'm going to say, so in Python we can do random.random, and we want to generate a number, so that this will generate some number from 0 to 1, and we want to multiply that by the length of self.val list, right? What that's going to do is it'll give us again a number between 0 and the length -1 inclusive. This will be a decimal. So what I'm going to want to do is I'm just going to say let's floor that. And after all this, what I want to do is return self.val list of some index rand. And quite frankly, guys, I think that's all there is to it. Let me move this over because I don't want my camera to be covering it. Let me just make sure this runs properly. I haven't made any mistakes. This is on line 17. This should be self.valdict, and I made the same issue here. Self.valdict. Sorry, guys. Index is not defined, so I keep forgetting the same thing. Self.index. Yep. Oh boy. Oh boy. What did I do here? 26. Sorry. This should have been equals I. I'm sorry. Oh man, I really don't want to re-record this. Okay, so it looks like it passed. I'm sorry if you guys were yelling at me for that. I know there was a mistake there. Let me try to submit this and make sure it's all good. Yeah. Okay. So it runs super quick. 99.94. That's got to be like a personal record for me. I do apologize, guys, for the mistakes, and I think I'll give you a little heads up in the video and just to acknowledge that I go back and fix this. So yeah, this is kind of make sure you can kind of see all of it. This is the final answer. Like I said, really interesting question. So the question itself had two main pieces of information that you have to really digest. One is this trick here in using both the value dictionary and list simultaneously. And then the other is actually how to go about removing items from both in a constant time manner. If you guys found this helpful, as always, let me know down below. If you didn't, also let me know down below, okay? Because I do want to know. Like the video, share, subscribe, like all that good stuff, all the stuff all the YouTubers say. And yeah, that's it for today. So yeah, we'll hopefully see more of these questions in the future, and I will see you guys next time. Peace.